Let's look at example 2. So this one deals with the company producing light bulbs and the life expectancy of the light bulb, how long it will keep shining, is normally distributed. So the average number of hours that the light bulb shines is 1,000. So I'm going to make my curve a little bigger this time just so I have room to write these large numbers. So the mean goes in the middle, that's 1,000. So it says that one standard deviation this time was calculated for us, and all of these will be, is 50 hours. So I'm going to go one standard deviation away on each side, and one standard deviation is 68%, so I have 0.34 here and 0.34 here. So this would be 1,050, and this would be 950, because that's 50 units away from 1,000. All right, so this is one standard deviation away. So now let's go 2 away. So 2 is going to be another 50, so this one is going to be 1,100. And this one's going to be 900. So now we're at 95%, so I need to add another 13.5%, so 0.135 and 0.135. I'm going to go the third standard deviation away, so 1,150 and 850, and that adds another 4.7%, so 0.0235, 0.0235, and then the outlier here at the end is 0.0015, and on the other side 0.0015. So these are beyond the third deviation. So this says what percent of the light bulbs will last for 1,000 hours or more. So that means I want to start here and go this direction. What percent happens? Well, that's half of our data. So this time it says what percent. So I'm not writing it as a decimal because it doesn't say probability. So it would be 50%, right? Half of our data should be at 1,000 or more because that's our mean. Okay, the second one, what's the probability that a randomly chosen light bulb will burn out in 900 hours or less? So 900 hours or less is here going this way. So I'm going to add 0.0015 plus 0.0235 together, and that number is 0.025. That's the probability. That's not very likely that that would happen. In fact, if I wrote it as a percent, it would be 2.5% of the time. That's not very often. Okay, the third one says, what's the probability that it will last between 850 and 1050? So 850 is here at 3 standard deviations away, and 1050 is here at 1 standard deviation away. So I'm going to add 0.235. I'm sorry, where am I at here? I'm going to add 0.0235 plus 0.135 plus 0.34 plus 0.34. And so the probability that that happens is 0.8385. That's pretty likely that that would happen because it's about 83.85%.